Hello, folks. Welcome to 3.7, measuring variability. Today we're going to talk about there's 4 different types of measurements to measure spread, which is what measuring variability is. It's how spread out the data is. So those 4 different ways would be range, interquartile range, variance, and standard deviation. So let's talk about what each of those are and go over some examples of them as well. Okay, so range takes the largest number in our data set. Let me see if I can zoom in a bit, and subtracts the smallest number in the set. And it gives us the difference between these two extremes. The larger the spread, or I'm sorry, the larger the range, my fault. The larger the range, the more spread out the data is. That's true for all these values. The larger the IQR, the larger the variance, the larger the standard deviation, the more spread out it is. So the larger the quantity, the more spread out the data is, the more variability it has. All right, so an example of range, again, it's just taking the largest value minus the smallest value and finding the difference. So with the starting salaries here, 47 is the largest and 37 is the smallest. So we're going to take the difference, 47, the largest, minus the smallest. 47 minus 37, that's 10. So our range is 10. Or if you apply it back in the context of the question, $10,000. Oops. Right, because these are all represented by thousands of dollars for starting salary. So essentially it's 47,000 minus 37,000, a range of $10,000. All right, IQR. IQR, what's good about the IQR is it doesn't consider extreme values. The IQR looks at the range of only the middle 50% of the data. So it's not the overall range, not the complete largest minus the complete smallest. It's only taking the range of the middle 50% of the data. So how does that look? Well, first thing we're going to have to do to find IQR is put these in order from least to greatest. We put them in order from the smallest numbers to the biggest. We have 37, 38, 39, 41, 41, 41, 42, 44, 45, and 47. So there are 10 values here. What we're going to do is we're going to identify the median first. There you go. So the median is going to be between the 5th and the 6th value. The median is going to be here, splitting the 41, 41. So average the two 41s up, and that puts the median at 41, of course. And Q1, so interquartile range is going to get broken into essentially these fourths. So we found the halfway mark, and now we're going to find the halfway of the first half. Essentially, think of a number line from 0 to 100, right? 50 is in the middle. That's essentially what the median is. That's where we're at now. But we're going to find the middle of the first half, which we put it at like the 25th percentile. So the median of the first 5 values is what we're looking for. So where's the middle of the first 5 values? Well, the median there is going to be 39. And this is going to be our Q1. We call it Q1 as in first quartile because it's the first fourth or first quarter of the data. Now, we also do the same thing for the second half. So what's halfway between 50 and 100? It's the 75th percentile. So that's going to be known as Q3, our third quartile. And same thing, we're looking for the median of the last half of numbers. So these last 5 numbers, the median of those is going to be 44. So 44 is going to be our Q3. So IQR focuses on the middle 50%. Essentially, from 25 to 75, right? 25 to 75, isn't that the middle 50%, right? 25, 75, that's 50%, and it's in the middle of the data. So that's what we mean by the middle 50%. It's essentially from the first quartile to the third quartile. So from 39 to 44. And our IQR is actually this range. So I didn't add it, but I'll add it now. Our IQR is calculated as Q3 minus Q1, the range of the middle 50%. So from 44 to 39, right? So in this case, it'd be 44 minus 39, which is 5. Or again, $5,000 IQR. All right. Now we're going to move on to variance and standard deviation. These kind of go hand in hand with one another. So variance is the average of the squared differences from the mean. So average of the squared differences from the mean. We're going to do all of those things here in a second. Average squaring the differences from the mean. A small variance indicates that the data points tend to be very close to the mean and to each other. One problem though with the variance is it does not have the same unit of measure as the original data. Now standard deviation is similar. It's the average amount we expect a point to vary or deviate from the mean. Now notice how both of these are coordinating with the mean, right? Not the median, but they are related to the mean. They're calculated based upon the mean. Whereas notice like IQR, for example, was calculated based upon median, right? We didn't find the mean for any of this part for IQR. IQR works hand in hand with median, whereas these work hand in hand with mean. And also a very important point, this is super duper helpful to know, is that it's the square root of the variance. So if you find the variance, all you do is square root it and you get the standard deviation. So if you find the variance is equal to 9, well, then you're going to find the standard deviation is going to be equal to 3 because that's the square root of 9, just as an example. All right. So let's go ahead and show you some calculations. So to calculate this by hand, it's a bit of work, but when I'm done doing it by hand, I'm going to show you a faster way to do it using a calculator. So first thing we're going to do is find the mean. So let's go back to, we're talking about this data. So we need to find the mean here of these values. So if you add these all up and divide by 10, which is what we have here, 10 numbers, you'll find that the mean comes out to 41.5. Right now, if you were curious how I calculated that again, you can go watch the 3.6 video where we find the mean and median on all those things. But just as a reminder, it's simply adding up all these numbers here, all 10 values, and then dividing by 10. All right, so here's what we're going to do. Find the deviation. So following these steps. I'm going to make a little chart here to make it a little bit easier to follow. So we're going to put the values here on the left. And it doesn't have to be in any particular order, but I will just go ahead and put them in the numerical order that they came in. So 37, 38, 39, 41, 41, 41, 42, 44, 45, and 47. All right, so what we're going to do is we're going to subtract the mean from each one of those values. So we're going to subtract 41.5 from 37. We're going to subtract 41.5 from 38. We're going to subtract 41.5 from every single number. And we're going to calculate those differences and just put those differences right here. So if we take the difference, this one's going to be negative 4.5, right? 37 minus 41.5 is negative 4.5. Then 38 minus 41.5 is negative 3.5, followed by negative 2.5, negative 0.5, negative 0.5, negative 0.5, positive 0.5, 2.5, 3.5, and 5.5. Now what we're going to do is square all those differences. Take every difference that we just found and square it. So negative 4.5 squared times itself. Negative 3.5 squared, which times it by itself. So remember, if you take a negative number and you square it, you're doing a negative times another negative, because you're doing a negative times itself, which should be positive. So all these numbers are going to be positive here. So if you take negative 4.5 squared, you'd get 20.25. If you took negative 3.5 squared, it'd be 12.25. And then negative 2.5 squared is 6.25. And I'll just carry on finishing these up. This one's going to be 0.25, 0.25, 0.25, 0.25, 6.25, 12.25, and the last one is 30.25. All right. So remember what the variance is. Remember, the variance is the average of the differences of the squared differences from the mean. So here's my squared differences. Now I want to find the average of them. But to do that, I need to add them all up. And then we're going to divide by something interesting. Divide by n minus 1. We'll talk about that in a second. But let's add these all up real quick. If you add up all of these squared differences, that comes out to a grand total of 88.5. All right, 88.5. So now we need to average it, but that means dividing it by n minus 1. So I'm going to take 88.5, but instead of dividing it by 10, because in this case, remember, n is 10, we're dividing it by n minus 1, which would be 10 minus 1. We're going to divide it by 9. I don't exactly remember why, but I know it is the formula. It's part of the formula. You can see it kind of emphasized here. Yeah, I don't remember exactly the reason why it's n minus 1. I know it's something to do with the fact that there's a value counted in there already. But I don't remember. Anyway, we follow the rule, divide it by n minus 1, which is 9. Again, n is 10 because there are 10 values. So if you're wondering, what is n? N is whatever number of values you have. So there are 10 values, that's why n is 10. So 1 less than that is 9. So we divide that, and we're going to get this to equal 9.833. And that right there is your variance. And then remember, to get your standard deviation, you just square root the variance. 9.833. The square root of that equals 3.136. This is your standard deviation. So standard deviation is really easy to get after you've already found the variance. Nothing fancy. You just have to square root it. That's all. See, it says that take the square root sub 6. So that's what we did. Take the square root. That's your standard deviation. All right. So that's how to do it by hand. It's pretty easy to follow. It just takes a little while because there's so many steps to it. But you have the values. You subtract the mean to find out how far away each value is from the mean. You square them. You add them up. And you divide by n minus 1. And finally, you would square root, just get the standard deviation at the end. So how do you do this without working it by hand? How to do it with the calculator? So if you go to the statsbenedict.com/applets, you'll click on this fourth option here, one quantitative variable single group. And this will do it for you. So I'll just put on our data. Remember, our data was 37, 38, 39, 41, 41, 41, 42, 44, 45, 47. Begin analysis. It gives us down here summary statistics. It doesn't give you the standard deviation. I mean, the variance. It gives you the standard deviation though. But it doesn't, like I said, it doesn't give you the variance. So if you ever need to figure out the variance, remember the standard deviation is just the square root of the variance. So if you were to take the standard deviation and square it, right? So 3.136 squared, you'll get the variance. So again, it's not written here, it's not listed here, but it's easy to find if you remember how to use the standard deviation to get it, right? You square the standard deviation, you get the variance. So easy to calculate from here. All right. A couple important points. You do want to know these symbols and what they mean. So for a quick example, let's say I took a sample of 50 students from the school and I found out what their average height was. And I said, oh, okay, so my average height of my students sample, 50 sample was, let's say 68 inches, right? All right, so I'd use this symbol because it's from a sample mean, a sample average. But let's say I got the average height from everybody in the school in general. And the average height from everyone in the school in general was 70 inches, right? Doesn't matter the number, but it's a symbol. This symbol means it's for the population representing the whole school, whereas X bar means it was coming from a sample. So they both mean average, they both mean mean, but one just tells you that your data comes from a sample, the other one tells you it comes from a population. And that's the same thing with, you know, the variance, standard deviation, and number of entries. The difference between those there. And then a really important thing to remember here is when to use each measure of spread. So symmetric or approximately normal, use a standard deviation, big deal. And if it's skewed left or skewed right, you're going to use IQR, big deal. So if you ever have to do SOX, and it's asking you, you know, shape, outlier, center, spread. Well, when you calculate when you calculate spread, you'll have to use the correct version of spread. Remember, there's 4 different types of spread: range, IQR, variance, standard deviation. So if the data was symmetrical, you would use standard deviation as the measure of spread, not anything else. If the data was skewed left or skewed right, you would want to use the IQR as your measure of spread, nothing else. So follow these. And if you remember, if you go back to 3.6, if it was symmetrical, this also used mean as its measure of center. And if it was skewed, it used median as its measure of center. And this is an important point to figure out or notice here because, well, remember the mean helped with the variance and standard deviation. The standard deviation works with the mean. So it makes sense that when you have symmetrical data, you're using both standard deviation and mean, things that work together. And skewed left and skewed right, remember IQR uses median, right? Is fundamentally based on median. So it makes sense that IQR and median go together when you have skewed left or skewed right data. So IQR and median are like peanut butter and jelly, right? And then standard deviation and mean are like peanut butter and jelly. Those things are just kind of paired together a lot of times. All right, I'm not going to do these final examples, but again, you can do them. This shows you the calculator, like on a TI-84 calculator. So if you want to follow these steps, you can. Or I showed you just recently how to use the StatsMedic website. You're more than welcome to, of course, you know, find the answers here using the StatsMedic website. But yeah, I'll leave it at that. And I'll call it a day. I'll see you guys in the next one. Bye-bye for now.